Welcome to the deep dive. Today, we're really getting into the nuts and bolts of Python programming. Specifically, how we name things, variables, functions, you name it, and just as importantly, how we organize all that code. It sounds basic, maybe, but it's fundamental. This isn't just about making the code run.
Exactly.
It's about clarity. It's about planning ahead. Our goal here is to kind of give you the essential guidelines, the rules, and the best practices for identifiers, modules, packages, basically a shortcut to writing cleaner Python without getting bogged down.
Right. And what's fascinating here is, as you said, it goes way beyond just syntax. We're talking about crafting code that's, well, readable, that someone else can pick up or that you can pick up 6 months later.
Oh, tell me about it. Future you will thank you.
Definitely. It needs to be maintainable, scalable. These early choices, they really do prevent headaches later. Makes debugging easier, makes working in teams actually work. It's like laying a solid foundation, not just stacking bricks hoping they stay up.
Absolutely. Perfect analogy. Okay, let's unpack this then. Let's start right at the ground floor. Python identifiers. So an identifier, fundamentally, it's just the name you give something in your code, right?
Pretty much. A variable, a function, a class, a module, it's the label. It's how you refer to that specific thing later on.
Like naming your pets, you need a specific name.
Yeah, exactly. And like naming pets, there are some rules. Python's quite specific. First off, what characters can you use? It's letters uppercase AZ, lowercase AZ digits 0, 9, and the underscore character. That's it.
Okay, letters, numbers, underscore. Simple enough.
But rule number 2 is key. It must start with a letter or an underscore, and absolutely cannot start with a digit.
Right. So one name is out, but name one is fine.
Precisely. That's a common one people trip over early on. Syntax error straight away if you start with a number. Rule 3, no special characters. Things like cake, at hashtag Hayes, dr%, forget about them in names. At email, nope, invalid.
Got it. Keep it clean.
Fourth, and this is important, you can't use Python's reserved keywords. These are the words Python uses for its own structure, like if, else, while, for, true, false, def, class. There's a whole list.
So you can't name your variable class.
Definitely not. Python would be very confused. Fifth, and this catches so many people, Python is case sensitive, big time. My variable with a capital V, my variable all lowercase, and my variable starting with a cap. Those are 3 completely different things to Python.
Oh, wow. Okay, that's a crucial detail. I can see how that would cause bugs.
Oh, it does. I've spent way too long debugging what turned out to be just a capitalization mistake. That happens.
Been there. Feels like you're chasing ghosts sometimes.
Exactly. And the last rule, no spaces allowed. Username doesn't work.
But username with an underscore is okay.
That's the standard way, yeah.
Yeah.
Username is perfect. So valid examples could be like age, total score, calcul average, database handler, even something starting with an underscore like internal value or item 123.
Okay, so knowing these rules basically stops your code from crashing immediately. It ensures Python can actually understand the names you're using.
That's the first hurdle, yes. Making it runnable.
But then there's the next layer, right? The conventions. The stuff that makes code, well, Pythonic.
Yes. Beyond the hard rules. This is where POP8, the style guide, really comes in. This is about making code readable, maintainable, collaborative.
Right, not just functional, but elegant.
Here's where it gets really interesting, I think, because these aren't enforced by the interpreter, but they're super important for humans. So for things like variables, functions, methods, attributes, the convention is snake case.
Snake case. So all lowercase with underscores separating words.
Exactly. Like userage or calculate tax owed makes it
Oh.
really easy to read multi-word names.
Okay.
But for class names, it's different. We use camel case, also sometimes called cap words.
Camel case. So like user profile or HTTP request, capitalizing the first letter of each word.
Precisely. It visually distinguishes classes from, say, functions or variables.
That makes sense. What about constants? Things that shouldn't change.
Good question. For constants, the convention is all caps with underscores, like max connections or PI. If you see that, you immediately know it's meant to be a fixed value.
Okay, clear signal.
And underscores themselves have special meanings by convention. A single leading underscore, like internal counter.
Yeah, what's that about?
It's basically a signal. It tells other developers, hey, this is intended for internal use within this class or module. You can access it from outside, but maybe you shouldn't unless you really know what you're doing. It's not enforced by Python, it's a convention. A polite keep out sign, maybe.
A gentleman's agreement, almost.
Kind of, yeah. Then you have the double leading underscore, like private attribute.
That sounds more serious.
It is, in a way. This triggers something called name mangling. Python actually changes the name internally to make it harder to access accidentally from outside, especially in subclasses.
Ah, so that helps avoid naming collisions and inheritance.
Exactly. It's a bit more advanced. You don't see it every day, but it's there for when you need that extra protection against name clashes.
Okay. And then there are the ones with underscores at both ends.
Right, the dunder methods, short for double underscore. Things like init for initializing objects, strens for how they're represented as strings, len for their length, add for defining what the plus operator does.
The special methods.
Yes, these are hooks that let your custom objects integrate deeply with Python's built-in behaviors. They're how you make your classes feel like native Python types. They're predefined, you don't just make them up.
So init isn't just a random name. It has a specific job the moment you define a class.
Correct. It's a constructor. Using these conventions, the single underscore, the double, the dunders, it all adds layers of meaning beyond just the name itself.
It really paints a clearer picture of the code's intent just by looking at the names.
Absolutely. This raises an important question. Why bother with all this? It ensures consistency. When everyone follows these conventions, code becomes easier to read, faster to understand, simpler to maintain, especially when you're working in a team, cuts down the mental effort needed.
Okay, that distinction between the hard rules and these softer conventions is vital. It's the difference between code that just works and code that's genuinely well crafted. So now imagine you've got all these beautifully named variables, functions, classes, following all the rules and conventions. Great. But your project is growing. You've got hundreds, maybe thousands of lines. How do you stop it from becoming one giant tangled script file? That sounds like a nightmare.
It absolutely would be.
Okay.
And that's where we move up a level in organization to modules and packages.
Our tools for structure.
Exactly. Let's start with modules. Simply put, a module in Python is just a single file containing Python definitions and statements. Usually it ends with .py.
So my functions.py could be a module.
Yep. Inside my functions.py, you could define several functions, maybe a class or two, some variables, all related to a certain task.
Yeah.
The big advantage is organization. You group related code together. Plus, modules create separate namespaces.
Namespaces, meaning?
Meaning the names inside one module don't clash with names inside another module or with your main script's names unless you explicitly tell them to. So you could have a function called calculateandmodulate.py and another function called calculateandmodulate.ki, and they won't interfere with each other.
Ah, okay. That avoids a lot of potential conflicts.
Huge conflicts. Think about Python's standard library. It's full of modules. You've got the math module for math stuff, OS for interacting with the operating system, datetime for dates and times, JSON for working with JSON data, random for random number.
You import those.
Exactly. You use the import statement. You do import math, and then you'd use math.sqrt to get a square root. Or you could do from math import scort, and then you can just use scort directly. Different ways to bring that module's functionality into your code.
Okay, so a module is one file, a container for related code. That seems manageable for, smaller sets of tools. But what happens when your project gets really big? Like dozens of files, maybe different major components. Just having a folder full of .py files could still get messy, couldn't it?
Oh, absolutely. And that's the problem packages solve. Think of a package as the next level up. It's a way to structure Python's module namespace by using dotted module names.
Dotted module names, meaning?
It means a package is basically a directory of Python modules. Critically, that directory usually contains a special file called init.py.
Right, I've seen those init.py files. Sometimes they're empty.
Often they are, yeah. Historically, the presence of init.py told Python, treat this directory as a package. It could also contain initialization code for the package, but just its presence was the main signal. Now, it's worth mentioning, in newer Python versions, you can have something called namespace packages, which don't strictly need init.py, allowing parts of the package to live in different places. But for most standard packages you create or use, you'll still see that init.py.
So a package is a directory containing modules, the .py files, and maybe even other directories which are subpackages.
Exactly. It creates a hierarchy. Think about big libraries you might use, like NumPy for numerical stuff, or Pandas for data analysis, or web frameworks like Django or Flask. These are huge packages.
Yeah, they must have tons of files inside.
They do. Hundreds, sometimes thousands, organized into modules and subpackages. NumPy might have subpackages for linear algebra, for random number generation, etc. Django has components for handling requests, databases, templates, all organized using packages.
And importing from them, how does that work with the hierarchy?
It follows the structure using dots. You might import NumPy, Or maybe you need something specific, so you do from django.http import HTTP response. Or go deeper. From matplotlib.backends.backendag import figure canvasag. The dots mirror the directory path within the package.
It's like a file path, but using dots.
Pretty much, yeah. It
Yeah.
lets you pinpoint exactly what you need from potentially very large structures.
Okay, that structure makes sense for big projects. So just to really nail it down for everyone listening, module versus package, what are the absolute key differences they need to remember?
Right, let's boil it down. Scope. A module is a single file, .py. A package is a directory containing modules and potentially sub-packages, identified typically by init.py.
File versus directory. Got it.
Organization.
Hmm.
Modules group related functions, classes, variables within that one file. Packages organize multiple modules and sub-packages into a larger logical hierarchy.
Okay, internal file organization versus project level hierarchy.
And purpose. Modules help with code reusability and organization on a smaller scale, within a specific functional area. Packages are designed for building, distributing, and managing larger, more complex applications or libraries. They handle complexity across the entire project.
Makes perfect sense. So start with modules, and as your project grows in complexity and size, you naturally start grouping those modules into packages.
That's generally the flow, yes.
Yeah.
If we connect this to the bigger picture, mastering modules and packages is fundamental to managing complexity in Python. It allows for clear separation of what does what, makes code easier to find and reuse, and honestly, it's what makes large-scale Python development feasible, especially in teams.
What a fantastic breakdown. We've really gone from the smallest naming detail, the identifier rules and conventions, all the way up to structuring massive projects with modules and packages. It's quite the journey, but you can see how it all connects. And I think the big takeaway here is, like you said earlier, this isn't just about ticking boxes for syntax. Understanding this stuff helps you write genuinely good code. Code that's clean, code that's understandable months later, code that works well with others.
Absolutely. It elevates your coding from just getting things done to actually engineering robust and maintainable software.
It really shifts the mindset.
It does. And maybe this raises an important question. As you go forward, think about how these aren't just hoops to jump through. These rules, these conventions for naming and structuring, they're tools, powerful tools that's designed to guide you towards clarity and collaboration. So the provocative thought might be, how could applying these principles, this idea of clear naming, logical grouping, hierarchical structure, how could that actually influence how you think about organizing information, or maybe even tackling complex problems completely outside of programming, in other parts of your life?
That's deep. Taking programming principles into the real world, a really interesting challenge to think about. Well, keep diving deep into these ideas. Keep practicing them in your code. You'll definitely see your Python becoming more intuitive, more powerful, and just, well, better. Thanks so much for that incredible insight today.
My pleasure.
And thanks to all of you for joining us for another deep dive. We'll catch you on the next one.